The purpose of this video is to talk about how to specify the Adsorber properties. Now we're getting into some interesting stuff where actually we're designing these types of the pack bed, right? Because a lot of what goes into these designing PSA cycle is pack bed, how to design the pack bed system. So basically we're configuring that within this spreadsheet here. So let's take a look at this together. So one of the things we need to be mindful are the initial conditions, right? So what do we mean by the initial conditions? Where we need some sort of state to begin our simulation because it's a dynamic simulation. So we're solving initial value problems and we need to provide initial conditions. So in this case, notice that we have two rows, one row for the bed 1 and then bed 2, right? Remember they're off phase by 180 degrees. So if one is producing product, the other one is undergoing regeneration, right? So consider initial conditions, different initial conditions with in this description column. Saturation with the feed at the high pressure, saturation with the raffinate product at the high pressure, and so forth. So we have even 9 different initial conditions to choose from. But here we have chosen 5. So what is 5? Saturation with the raffinate product at the low pressure. So remember, why are we choosing this initial condition? Because for the adsorption column 1, if we refer back to the pressure profile, it starts out at a low pressure. That's kind of clean, right? Because the beginning state of the initial state for the bed 1 should be pretty much the end of the purge step where you are at a low pressure and then you purged out all the residual heavy heat from the void space. So that perfectly kind of corresponds to the saturation with the raffinate product at the low pressure. That's basically telling us the condition that's really close to what's there after you finish your purge step. So that's all nice and well, and we can move on to the next initial condition, right? So what is this initial condition? Where for the first bed, we are about to start repressurization and high pressure feed. So we set our initial condition to be saturation with the raffinate product at the low pressure. But for the bed 2, it's about to undergo depressurization and then purge, right? So it's about to undergo the regeneration step, part of the cycle. So what should be the pressure be? It should be a high pressure, right? It should be a high pressure saturation with the high pressure feed almost, because basically it's trying to get at what it's trying to get at is the condition at the end of the high pressure feed where the majority of the bed should be saturated with the feed. It should be at a high pressure. So that's why we're choosing initial condition number 1. So hopefully that makes sense to a certain extent, and toPSAil provides this list of different initial conditions to be flexible enough for the PSA cycle that you're interested in simulating. The next one is also interesting. Although the geometry is a critical factor in, especially when you actually solve this system of simulate PD by solving it as a system of partial differential equations, then this geometry even matters more. But toPSAil, we're assuming it's we discretize along the axial direction, right? So it's 1D model. So we basically have to provide, of course, the height of the pack bed, and then the interior and exterior radius, right? Radius, interior, and outside. So the difference between the interior and the exterior outside radius, it's going to be the thickness of the casing, or how much metal we use to provide this pressurized vessel. So that's what's happening here. And then void fraction of the bed, it's bed porosity, right? So basically you assume spherical pellet and draw the boundary around this pellet, and then whatever void space between the casing of the pack bed and outside of these spherical pellets, we take that void space into consideration. So this is the definition of the void fraction. And then mass of the adsorbent is basically how much, what's the amount of the adsorbent we're filling inside the pack bed. And adsorber design, of course, we need to specify the desired high pressure target and the desired low pressure target, and as well as the isothermal temperature, or this is also going to serve as an initial temperature as well. And then we need to provide the physical properties, the density of the column wall, right? That's obviously good information to have. And then especially when you run non-isothermal simulations, we need to specify heat transfer coefficient as well as the heat capacity of the material that's consisting of the column casing. So those kind of informations are additional information that you need to provide. But as I mentioned, designing the packed bed adsorption column is an art, and there's actually a golden book for PSA bread and butter, or golden standard, I guess the Bible of the PSA, book written by Dr. Farouk and Ruthven and Dr. Knaebel. Dr. Knaebel in particular from the Ohio State University, and he has a startup company. So when he taught at Ohio State for a couple long time, but then he launched his own company called Adsorption Research Incorporated, and then they do a lot of stuff with Adsorber packed bed design and control for the natural gas applications as well. So these are actually practical stuff, and he has a white paper on how to design a packed bed if you're interested in. Yeah, thank you so much.